Kinetic, right? Has to do with rate. So the activation energy tells us about the rate of the reaction. Good. Did that cover Arrhenius? Who asked the question? I forgot. Oh, yeah. Is that good?
Yeah.
Okay. Is this sign right? I think the sign's right. Does anyone have the notes? Yeah, I think it is. Okay, other questions? So I looked at the homework. So when I was grading the homeworks, and for people who are going to listen to this at home tonight, some of the homeworks were very dicey in terms of figuring out E0 cell. People were getting signs really confused. People were multiplying and dividing when they shouldn't have, not being able to figure out N. And so I encourage you to review very closely my solutions to the homework and think about how the E0 cell is computed, because there was some some solutions weren't so hot that I saw in the homework. So please review that. I think all of my solutions are correct, and of course I'm around tomorrow, I'm around Tuesday morning, so you have some time to figure it out if you can't manage it on your own, or from the notes. Yes?
Should we learn how to figure out the ordered reaction from a table, like you give us like a table with the concentrations of rate?
That's a good question. So she said, what if I just give you a table like this? So I give you rate, and I give you concentration of A, and I tell you that the reaction is A goes to B plus C. And so the rate is 1, 3, 7, 9. The concentration of A is 0.2, 0.46, 0.71, 1.3, something like this. From this table of data, how do we figure out if something's first order, second order, 0th order? Go ahead.
You plot it in the different ways.
That's right. So you can't just look at it and decide. You have to make plots. So what do we plot for 0 order? Concentration of A, time, and if it's a 0th order reaction, how's concentration of A going to change with time? Straight line going down, right? What if the line's curved?
Okay.
Then it's not 0 order. So then we have to do first order. What plot do we make for first order? Natural log of A. Is this one going to go up? Going to go down? Going to stay the same?
Same straight line.
Down, right? If it's a straight line, that means that this is first order. If it's curved, that means it's not first order. We have to move on. So for second order, what do we plot? 1 over concentration of A. What does this plot look like? It's going up, right? Because if concentration of A is going down, 1 over A is going up as a function of time, so this is linear. So all you have to do is, maybe I'll give you graph paper on the exam or something like that. You can quickly make these 3 plots. So you make another line with ln A, make another line with 1 over A. Put down the values, quickly plot these things, and you'll be able to tell which is a straight line or not. Go ahead.
You think algebraically, like the other way, without like doing the graphs?
Sure, you could do it algebraically if you want. How would you do it algebraically? Go ahead.
We watch like the first 2 lines, then we like them, because R equals K times A to the X times B to the Y, then we divide to the 2 equations, then we'll still have the X. When we solve for X, then we find the power of X, A, then do the same thing and find Y, then add X and Y, we'll get the total.
Yeah, I know what you're doing. I think that would take more time than doing this. What I suggest you might do is, if you make these 3 columns, you can figure out which one is linear just by looking at the slopes for each of these pairs, right? Because you've got this pair and this pair. Figure out what that slope is, figure out what this slope is, figure out what that slope is. And then you do the same with this. Figure out what these slopes are, these slopes are. So from that you can figure out which is linear. But what I would recommend is you make the plot, because then you really can't be wrong and you don't have to do 56 math things. Yeah. So you could do it algebraically if you want. But I suggest the plots. Those are easy to see. Okay, other questions? Yeah.
Can we go over number 6 and
Sure.
in homework 10?
6 in homework number 10. What was the question?
It was the everything with copper and silver.
Ah, great. I don't think I brought my solutions. Okay, can I see someone's homework? Great. Okay, a block of copper and a block of silver were put together. So we have a block of copper and a block of silver. And of course we're going to have a little water in between there, and so we're going to have some ions. And so if you had to pick one of these metals, which one's going to corrode? Copper's going to corrode, right? How do you know that? It's less noble. You can look on the noble metal series. That's fine. You can look at the standard potentials and figure it out. But let's just start with copper corroding. So what reaction are we going to have with copper? So we're going to take copper. What's going to happen to it? Okay, so it's going to go to Cu plus 2 electrons. What's the standard cell potential for that? What is it? 0.34 volts.
Oh, I'm sorry.
Is that right? I don't have my table with me. Let's just assume that's correct. Okay,
Yeah.
so copper metal is going to corrode to copper ions. This is anodic. It's the anode reaction. It's an oxidation, so copper is going to corrode. What's going to happen to silver? What's the other half reaction? We can just assume that silver is going to be reduced, right? I don't tell you anything about oxygen. Some people wanted to talk about oxygen, and that's fine. Homework sometimes is open to interpretation. But the easy way to solve this problem is just say silver is going to be reduced. And so we have 1 electron reduction of silver in this case. What's the standard cell potential for that? 0.8. Do I have my signs correct in terms of the directions of all this stuff? Copper's negative?
Yeah.
Okay, I don't have my table, so I don't know. Am I good now?
Yeah.
Okay. So right away we know that silver is more noble than copper, so silver's going to tend to be reduced. Copper's going to tend to be oxidized. You could do 1 electron oxidation of copper if you want, like Matt has here. Yep. So you can have 1 electron oxidation. That's got a different cell potential. You could balance this reaction. So, okay, I'm going to balance this thing. What do I do to this? Nothing. So I can write my full reaction if I want. And the easy way to figure out what E0 cell is you just add these up, right? So what's E0 cell? 0.46.
Yeah.
Great. So remember, no multiplying. Make sure you get the signs right, and you just add things up. Make sure that your electrons balance, all that stuff. So in this case, N would equal 2. So I could ask you what the free energy was for this reaction. So delta G equals -2 times Faraday's constant times 0.46. Is this a thermodynamically favorable reaction? Yes, it is, right? That means it's going to happen. Copper is going to corrode. What if I told you, so I could give you a problem, and I could give you E0 cell, and if the E0 cell was negative, I could say, is this reaction going to happen or not? And you would say, no, it's not thermodynamically favorable, so it won't happen. but the reverse reaction will. So silver, when it's in contact with copper, will never corrode, right? Because this E0 cell, if we change the direction of both the anodic and cathode reactions, this E0 cell will be negative, which means it'll never happen, or it's not thermodynamically favorable. So on the homework, you could have had 1 electron oxidation of copper, you could have had other things going on, but in general, this is how it's solved. So the answer for 1 electron oxidation, if you had copper going to Cu plus E negative, so this is only taking 1 electron off copper rather than 2 electrons. The standard cell potential for that is negative 0.52. And so the E0 cell, according to Matt, is 0.278. I'll trust him. And so either of those were okay. So cover it on that one?
Yeah, is using one of the copper reactions over the other one better?
No.
Or are they?
Well, I mean, you could use, so in some cases, the one with the lower potential is going to occur first, right? So this one's, the 2 electron is lower energy, so it's going to occur first. However, unless I tell you explicitly which one to use, either is fine. And on the exam, I'll have a table of standard potentials for you to use. I'll tell you which reactions to use, so there won't be anything open to interpretation on the exam. Yes?
Can you please explain why the further apart two alloys of the Phoenix series, the worse the corrosion?
Can I please explain what?
Why the further apart two alloys of the Phoenix series, the worse the corrosion? Like what's the
Where does it say that? In the notes?
Yeah.
Let me see.
You don't have a question here,
The further apart alloys are on the galvanic series, the worse corrosion. I don't think we covered that in corrosion, so you don't need to know that. Yes?
Can you give us the order of the metal chart?
Yeah, that will be on the exam. Yeah. Or whichever question about noble metals I give you, there will be some sort of chart to figure it out. How so say I didn't give you the noble metal chart, and I asked you which metal was more noble. How'd you figure it out? Go ahead.
Deduction.